Hi everyone. Here is the problem we will be working with today. Looking at the question, it is asking us to determine the local maxima and minima using the first derivative test, then confirm the answer with a graph. A problem that someone could run into while working on this question is not knowing where to start from. I would suggest before starting any question similar to this, start by creating a step-by-step plan on how you will approach this question. What this means is, instead of jumping right into the question, take a moment and physically write the steps you will take to find the solution. For this question, a possible plan would be starting by finding the first derivative, then setting it equal to 0, and finally graphing f of x to check if the answer is correct. With this approach, by breaking down the question to individual parts of a plan, it relieves some of the initial confusion on how to solve the question.
When we are given a question asking us to find the local maxima and minima of a function, one of the easiest and most effective strategies we can use is making a graph. In this question, we are given a positive third-degree polynomial, so we know the graph should look something like this. However, this does not actually tell us the exact points of any local maxima or minima, it only tells us the zeros. To find the exact points of any local maxima or minima, we will need to obtain the first derivative of this function. This shouldn't be too difficult, however, as it is only a matter of applying the power rule. We know that f of x will be equal to some positive second-degree polynomial. This tells us that the graph will look something along the lines of this. From this graph of the first derivative, we can figure out the local maxima and minima of the original function. Recall that the first derivative is equal to 0 at any critical point. If we analyze the graph of the first derivative further, we can determine whether each of these points is a local maxima or minima. Here, the first derivative is going from positive to negative, which means that this is a local maximum. Here, the first derivative is going from negative to positive, making this a local minimum. Now we can compare the graph of the first derivative to our earlier graph of the original function. We can see that it does have a local maxima and a local minima at about the same x values as we identified in our first derivative function. You now have a solid strategy for solving problems asking for local maxima and minima of functions. I hope you found this video informative, and good luck on future problems.